Welcome to Get Your FRQ On. This question is from 2021. It is question 4, and it is not calculator active. In the question stem, we're given a continuous function f, which is defined on a closed interval from -4 to 6. And we are given a function g of x, which is equal to the integral from 0 to x of f of t dt. In part A of the question, we are asked to determine where g is concave up and to justify our conclusion. Well, by the fundamental theorem of calculus, g prime of x is just f of x, and g double prime of x is f prime of x. The graph of f is provided in the question stem. It consists of line segments, so the slopes should be relatively easy to find. So g of x will be concave up whenever f of x is increasing. Well, based on the graph provided, f of x is increasing on the interval from -4 to 2, as well as on the interval from 2 to 6. In part B, we define a function p of x equals g of x times f of x, and we are asked to find p prime of 3. Well, in order to find p prime of 3, I have to find a rule for p prime of x that would require the product rule. So by the product rule, p prime of x is g prime of x times f of x plus g of x times f prime of x. Therefore, p of prime of 3 is equal to g prime of 3 times f of 3 plus g of 3 times f prime of 3. In order to find g of 3, we need to find the value of the integral from 0 to x of f, from 0 to 3 of f of t dt, and then the values for f of 3 and f prime of 3 we can get from the graph, but also notice that since g prime is f, g prime of 3 we get from the graph. It's just f of 3, and that graph is provided. So when we get around to evaluating p prime of 3, we get -3 times -3 plus -3.5 times 1. If we simplify that, we get 5.5 for the value of p prime of 3. In part C of this question, we are asked to find the limit as x approaches 2 of g of x over x squared minus 2x. Notice that the limit as x approaches 2 of g of x is 0, and that is the same as the limit as x approaches 2 of x squared minus 2x. So we're going to get an indeterminate form here, and we're going to have to find this limit using L'Hopital's rule. All right, so the limit as x approaches 2 of g of x over x squared minus 2x is the same as the limit as x approaches 2 of the ratio of their derivatives. But since the derivative of g is f, we can just write the derivative of g as f. So we have f of x over 2x minus 4. And since we have a graph for f, we can just figure out what f of 2 is directly. F of 2 is -4. And then if I substitute 2 into the denominator, I get 4 minus 2, which is 2. And when I simplify that, I get a limit of -2. In part D, we are asked to find the average rate of change of g of x on the interval from -4 to 2. And then we are asked if the mean value theorem applies. That is there a value of c on the interval from -4 to 2 where g prime of c, or f of c, is equal to that average rate of change, and then to justify our conclusion. All right, so g of x, right, if I want the average value, or average rate of change, I can just do g of 2 minus g of -4 over 2 minus -4. All right, so 2 minus -4 is just 6. G of 2, I can use the graph to find the value of g of 2 as a definite integral. Same for g of -4. And we get 16 over 6, which reduces to 8/3. All right, so the average rate of change of g on the interval from -4 to 2 is 8/3. All right. Does the mean value theorem apply here? Well, we're given that f of x is continuous on -4 to 6, and that f of x is g prime of x. All right. Now, since f of x is continuous on that interval from -4 to 6, f of x exists for every value of x on the interval from negative 4 to 6. So g prime is a continuous function on that interval, which means that g of x is differentiable on that interval from negative 4 to 2, right? Because negative 4 to 2 is a subinterval of negative 4, 6. But since g of x is differentiable on that interval, it's therefore continuous on that interval, which means the mean value theorem does apply. G of x is differentiable on the interval, so yes, there is some value of c between negative 4 and 2 such that g prime of c is equal to 8/3.